Hey guys, welcome to this video where I am going to tell you how I solved the assignment my sir gave us. And as you can see, there are a lot of features, and uh, uh, I want to make it pretty simple how I did this model and the procedure I took to completing this model. So let's see. So uh, I hope you guys can see the screen. Yeah, these are all the features in the dataset which our sir gave us, which my sir gave us, and these are all the features of the training set, and the test dataset only didn't have this feature. Yeah, this is the only feature missing in the test dataset, which means this is the thing we need to predict. This should be y. The and remaining all are the features which we need to use to make the model. So remaining all features can be used for x, and out of this let's just think and see which features can be used. Teacher id. Yeah, so basically the question is uh, analyzing all the features, we should say if a teacher's project is approved, should be approved or not. Yeah, okay, so yeah, let's come from start. Teacher id. A teacher id doesn't have anything to do with if her project is approved or not. This doesn't matter. Teacher prefix, miss or mrs, her gender doesn't matter. School state, that doesn't matter. Project submitted time or date, this thing also doesn't matter as long as she is submitted within the deadline. This thing actually matters, we can be skeptical about this. This thing also kind of matters, we can be skeptical about this. This thing also kind of matters, we can be skeptical about this. This thing yeah, this thing it will be, actually we can also take these or essays also into consideration, but it will make our code too complex, and you know what happens when the code becomes too complex, it overfits. So let's exclude this. Essays are big, so let's just exclude the essays. And yeah, summary also excluded, since it will also make the code too complex. And the teacher number of previously posted, this thing is important, this is important, this is important, this is important. Okay, let's now analyze out of the skeptical ones which can be used. In the project grade category, there are only four options. uh, yeah, these are the only four options the project grade category has. Since there are only four, with the use of one hot encoding, we can change this thing also into numerical data. As you guys all know, this thing is numerical, this thing is numerical, this thing is numerical, and these things are also numerical. But these three, the things which we are skeptical about, are characters. Okay, out of this the project grade category has only four categories. So with one hot encoding we can turn it into numerical. How, you ask? We can do something like what one hot encoding does, can be your question. What is this? Simply put, it changes this main column into the number of categories. That is, this column is changed into these four columns. I mean, I will put it in a better way. So this is what's happening. Yeah, so this column is getting converted into four columns. And yeah, how does this make sense? And I will show you how it makes sense. Grades third to fifth. Yeah, this is how it works, right? If the first one is grades to pre-KG, this becomes 1 and remaining all becomes 0. Second is 3 to 5, this becomes 1, remaining all becomes 0. If the third one is also 3 to 5, then this becomes 1, this all becomes 0. If the fourth one is 9 to 12, this becomes 1, this all becomes 0. This is how one hot encoding works. basically uh, the option which comes, that becomes 1, indicating the presence of this one becomes true, and remaining all these things did not come, right? So they become 0, that is false. This is a one hot encoding for this thing happens. This in similar fashion it can also happen for these things too. So we are taking this into consideration since we can do one hot encoding. Let's think about project subject category. A project subject category, we can actually also take it into this because it has 4 options, but there is an exceptions, because sometimes there are two subjects in the same thing, two subjects, which means 4 power 2. 4 power 2 is 4 into 4 is equal to 16. We need to convert this one thing into 16 things, which makes it very complicated and the code becomes bigger. So let's also exclude this thing from the batch, and since this thing is also similar, let's also exclude this thing. So the only things we are considering for creating the model right now is project grade category, teacher number of previously submitted, this thing, uh, this thing of previously posted, uh, project approved, total quantity, and total price. Yeah, these are the only things we will be taking into consideration right now while creating this project. So let's get into the coding part. Okay guys, before directly going to the coding, let's just first go over what we are going to do. So for okay, so I will just explain a small concept before going into there. Scaling, we will also be doing scaling here because uh, from the above one we know that we have 5 features, right? In this 5 features, one feature is the project is approved thing. I'm sorry, is project is approved thing, which we can't use you know for X part, since this project is approved thing is stored in Y. The thing we want to predict will always be stored in Y, and the model is mainly uh, created and trained using the values of X. So we will have only 4 features since the project is approved thing is stored in Y and the remaining ones are stored in X. And the features which are stored here are, as we know, number of previously posted projects, total quantity, price, and these things. The you guys know the project category, right? We changed this project category into 4 things, and this, yeah, we have a total of 1 2 3 4 5 6. We have a total of 6 features for model training. And wait 6, no, yeah, 7 features, 1 2 3 4 5 6 7. Since this project category thing is converted into 4 features and we have 3 features other than that. But look at this, I will just write the first 2 columns of the data and you guys will notice a small problem. 409 0 0 0 1 0 1 649 0 0 1 0. Okay, so what we can see is some values are really big and some values are really small. We can see that the price will always be high and this thing will always be low. What the model will think when we are sending data like this, it will think that this price thing is very significant, this is very significant, and these are very least significant, these are almost useless. We don't want that. We want each and every feature here to have the same weightage. So what we are going to do is called scaling. We are going to scale with the use of this feature called standard scaling. We are going to scale all these features by very easily. by like writing 2 lines of code, and these things with the different values, which makes us think that they have different weightage, will get converted into something like this. Look, minus 0.2, 0.3, minus 0.7, minus 0.4, minus 0.3, 1.2. See, now these things are very closer in weightage. So having features like this is better than having something like this, because because the difference between the consecutive features is very large. So the model might overfit, thinking this thing is useless, we will only use these features, something like that. But having features like this will make it so each feature is getting equal weightage. Okay, with this out of the way, let's just go over how we are going to write the code. Okay, so first we are going to load the training data into a data frame. After loading this, as soon as we got the data frame, we will do one hot encoding on the project category column, project project category column. Soon after that, we will make x and y. This x will have like you guys know, right? From the top, 1 2 3 4 5 6 7 features. This y will have one feature, since these are actually supposed to be like 5 features, and 5 and 4, this got divided into 4 and 1. In these 4 features, one feature got turned into 4 features, so 4 plus 3 is equal to 7 features for x, and one feature for y, and one feature for y. Okay, we got x 7 features and y 1 feature. And after that, we will do standard scaling on x, standard scaling on x. So all the values are similar, and all the not similar, so that all the values have equal weightage. After that, we will do train test split. So we are dividing training data and testing data. We think it's like a crucial part, because while doing train test split and making the model individually and testing, you guys can know the accuracy of the model, which is very important, since without knowing the accuracy of the model, we don't know if the model is good or bad. We will do train test split. After that, we will create a model with any one classifier, it doesn't matter which one. But in this case, for classification problems like this, I have seen that decision tree works pretty good most of the times, so we will go along with decision tree this time too. And after that, we will just calculate the accuracy and see that it's just doing all good. After that, we will load the test data. After loading the test data, we will also do one hot encoding on the test data. And after doing one hot encoding on the test data, we will get the new x. Since we just created model with the old x, but we need to predict to y for the new x. In this test data, only the values of x are given, no y are given. But for the previous one, x and y are given, and we created a model using these two. But for this one, we have only x, but we already have the model which we have created using the previous x and y. So what we are going, so basically just think of it like an equation. For the previous one, we got x plus y is equal to 1. X plus y is equal to model. But this time we only have x new, we don't have y, but we have the model. So what we can do, we can, with the use of this thing and this thing, we can just figure out this thing, right? Don't think of it like a plus, but just think that with the help of this thing and this thing, we can now make this thing up. That's what we are going to do. We are going to put the x new values in model and get the y values. Okay, so we now only have the x new values, which we will get from the test data. We will just write a line of code. X new is equal to the columns of the test data which we want for predicting y. We'll scale this again. We will scale this, and we got the scaled values, right? X scaled new. This this we will put into the model and get y values, and after getting the y values we will just convert this y values into a CSV file, and that's where our code ends. That's what I am going to do now with coding. Okay guys, this is the code I have written for the explanation I have given. Loading some important libraries, loading the training data, the one hot encoding process for converting this project grade category into four columns. Yeah, this is the whole one hot encoding process. I created the x and y variables. The x only includes the features which we will need for the model creation, and y will be the thing which we will be predicting in the future. And I printed x, which will be these things. Yeah, a total of 7 features, but we can see that there is clearly different weightage for different features because the difference between two features is far too big. So we scaled the features next using these lines, and after scaling, I converted it back into a data frame. I just use different names instead of direct x because it will be easier to just refer to the variable as x in the future. I did x normal here, and I created x1, which is just an array. The x1 is basically the array of scaled features x normal. Yeah, and x is the data frame. See, this thing got converted into this. Now we will put this into the train test split. We will create a model and check its accuracy. We got here 75%, which is pretty good considering that we have removed many features out of the training data. After we have successfully created the model and got a good accuracy, we will now load the test data, and we will do the same one hot encoding process for the test data too, because if the training data and test data are both different, the model won't accept it. The model needs both the data to be exact in same syntax for it to evaluate it easily. I also created the x new one, which is basically this thing, the x, the data frame of x values in this format, and then I scaled the features again into x new, which is this thing, and I put this thing into the model. I predicted y new predicted test values by writing this line model. I put the x new in the model and got these values, which is this. So basically, a y new predicted test is in array format. We got the values, but it is in array format. So I converted this array into a data frame with its column name predicted label. So after I run this line, I basically get this file, which is basically a data frame or a data frame of all the predicted values. Yeah, once I will show the code slowly so you guys can maybe take screenshots or something. Yeah, okay guys. So thank you for watching this video.